Start this. All right, it's recording. So first thing is variance. So there's three types of variance we talked about. A direct variance. A inverse variance. And a direct variance, an inverse variance, and a joint variance.
It's the one where it goes like this.
Yeah, you'll see. No, it's not the graphing yet. If that's what you said, I didn't
There's
know.
no graphing on this at all.
There is graphing on this. That's 5.2, 5.3.
Oh, yeah.
All right, direct variance. So, for example, if I told you if x is directly variant to y,
They're both going up.
they're both going up at the same time. So you should know the formula looks like this. Y equals ax. Some versions, if you look this on YouTube, might be k value. That's the same thing. It's some constant. Kx, yeah.
Oh my god, I was on X.
Yeah.
Directly variant to the
So if I say directly variant, so this is how the question basically works. It is, I tell you, when, well, I guess I could type this. When x equals 3, y equals 15, what is y when x equals 7?
Is that the A over X?
For this one is direct variation, so it's just a times x. So first you figure out what your a value is. So 15 equals a times 3. In this case, divided by 3 on both sides, 5 equals a. The first part's easy. Then I follow up with what is y if a new condition. So then you plug in 7 and to solve for y. 5 times 7,
So that part's easy then.
yeah, y equals 35. The trick of this section is not necessarily math, is knowing direct variation, a is multiplied with x.
Inverse is divided by it.
In inverse variation, y equals a divided by x.
Because you know inverse is divided.
Yes.
Yeah.
X is directly variant to y.
And then joint is.
Yeah. I just wrote that really quick. Don't worry
And then
about
joint
that.
is both.
And joint, it can't be both at the same time. Joint is used when you have multiple variables. So I can write in this case, z is jointly varied with x and y, and inversely varied with I'll put g. Okay. Which means in this one, the joint variation one, it would be z equals anything jointly will be on the top, x, y, a, and then anything inversely will go on the bottom, in this case g. So the whole key of this is not necessarily the math. The math is straight easy. It's just knowing the words and knowing how to set it up. After you set it up, then it's algebra 1.
Where's the number? The X.
Let's do one with numbers. So in this case,
Yeah.
when z, wait, when x equals 3, y equals 4, g equals 2, then z equals, no, it has to be a number. Let's say, let's do 15 again. I think that would work. No, let's do 30 just in case. What is z when x equals 5, y equals negative 2,
Coach, you guys smile?
g equals
Look at that.
4. Okay? So the first part of this is when x equals 3, y equals 4, g equals 2, then z equals 30. So in this case, we're going to plug it in and try to solve for y. So 30 equals 3 times 4 times this mystery a over 2. 12 over 2 is 6a. So divide by 6 on both sides. 5 equals a. Then, since I found A, I can use it with these numbers to find Z. Z equals 5 times -2 times 5 all over 4. -50 over 4. Z equals -12.5. Yeah, go look at it.
Which one is that joint?
That was a joint one.
Did we do inverse?
No, but inverse is just with a division symbol. So the setup is exactly the same. Just know this X should be on the bottom in that case.
How do we know when you like word a problem or something?
If I say jointly, then you know it's going to be on the top. While if I say inversely, it's going to be on the bottom. This is a word problem, but it's like the most simple word problem I can ever make.
How do you get negative?
No, like I'm not going to give you a story to it. It's just straightforward. What?
Oh.
3 times 4 is 12. This one.
Oh, because you used what you got for A. Sorry.
Yeah. So here's your A. This was your X. This is your Y. This is your G.
So essentially, on the first problem, you're figuring out what A is, and then putting that value to find Z.
Exactly. Or whatever I ask you to. Yeah.
Okay,
Alright.
in the concept, right?
A should be a constant, yes. All right. So that's 5.1. 5.2. Graphing. Simple function. All right. Okay. For this one is going to be. Actually, I'm going to do 5.2 and 5.3, which is also graphing rational functions. They're just a little bit more complicated. I'll just put it all in one section.
Thank you.
Okay. So, in this section, we have a polynomial on top and a polynomial on bottom. Usually we call that P of X over Q of X. So, for example, I could have something like x squared plus 3x minus 4 over, let's say, x plus 2. Yeah. Now, there's 3 scenarios that could occur. I'll do that also, don't worry. But in this case, in this scenario, you have P is bigger than Q, and that's based off the largest power you have, okay? And in this case, you have 4 things you're looking for: a horizontal asymptote, a vertical asymptote, x-intercept, and y-intercept. Now, the horizontal asymptote depends on the P and Q, so I'm going to talk about that first. So in this case, for P and Q, if P is greater than Q, aka the top has a higher power than the bottom, there is no horizontal asymptote for the horizontal asymptote.
Do they ever have like the same amount of X going?
That could happen. So this case will be a no horizontal asymptote one. And I guess let me just do this one, and then I'll do one that's equal and then one that where Q is bigger. So to find the horizontal asymptote, I base it off my PQ situation. In this case, P is bigger than Q, so no horizontal asymptote. So we put a slash like this, or a null symbol, not 0, null. Now this comes, the vertical asymptote. The vertical asymptote is where x cannot, or the function cannot exist. So for this one, what you do every time is set Q of x equals 0. You make the bottom equal 0. So in this case in particular, it's x plus 2 equals 0, x equals -2. So you have a vertical asymptote at x equals -2.
So your horizontal
Is based off the PQ. We only did one version of it.
based
Well,
off of like the numbers or
the powers,
based off the powers.
and the biggest power of them. Okay. We have
Why is the 2 not bigger than
2 is bigger than 1.
So when we're doing,
So P is bigger than Q.
so it's horizontal. Oh,
So if P is bigger than Q, then the null for horizontal asymptote. It does not exist.
So that means it is. Okay.
Yeah. X-intercept. The x-intercept, you make the top equal 0. So you make P of x equals 0. Which means I make the top equal 0. I'm going to do the work down here. 0 equals x squared plus 3x minus 4. In this case, I'm going to have to factor. So x minus 4, x plus 1. After that, I split and solve. So you got negative or positive 4 as one of your answers, and negative 1 is your other answer. So you could have multiple x-intercepts, 4 and negative 1.
Why can't you like just bring the 4 to the other side and like square root it?
Because this has an x1 power. So if you square root it, you're left with a square root x. So that doesn't help you. And there's a plus sign also. That makes it a problem too.
That's plus 3x, right? So how do you end up with negative x minus 4x plus 1?
Oh, that's my fault. You're right. So x plus 4, x minus 1, which means these are going to be flipped. This is positive and this is negative. Negative 4. Negative 4, positive 1. My fault now. Thank you. Okay. It's
That's add up. Plus
positive 3, so it should be positive 4, negative 1.
plus 1 is
I was thinking ahead of this. Like I gave the answers.
Yeah,
It's
you
fine.
gave the answer.
All right, so this one, y-intercept, what you're going to do here, I'm going to make the x-is equal 0. I'm going to write that as f of 0, aka unplug everything 0. So in this case, I'll do it down here. It's going to be 0 squared plus 3 times 0 minus 4 over 0 plus 2, negative 4 over 2, negative 2. So negative 2 is your y-intercept, okay? So these things you're going to have to find. That'll be one part. And then you have to graph this. When graphing this, use your calculator. Why make your life hard? So make sure you have your calculator for this.
What's in 5.2?
5.2 is one. I'll show you that when we get there. But they're kind of related, so that's why I'm going to put them together.
So we just did 5.3 kind of.
This would be a 5.3 thing.
How did you factor the thing again? Is it like 4 and negative 1 is 3?
1 multiplies to negative 4, that adds to positive 3. So x squared plus 3x minus 4 divided by, make sure you put parentheses or it won't work, x plus 2. When you graph this, you notice these kind of weird shapes. So when you graph it for your test, you will have grid lines, so you don't have to like actually put this here. The things you have to put in is horizontal asymptote. Do you have any horizontal asymptote? No, so you don't have to draw that. Vertical asymptote. You have a vertical asymptote at x negative 2. So you're going to have to put a dotted line at x equals negative 2. Your x-intercepts, you're going to have to draw those points. That's at negative 4, so there's one part here. And at positive 1, so one part here.
You don't have to graph this, even though we have the calculator to graph for it.
But I wanted you to graph the points that you found into the thing. So,
I thought the y is negative 2.
oh, negative 2, you're right. I put
That's why
positive.
I'm not gonna graph it, because then I want you to read it so clearly on the calculator.
Well, when you graph it, your function of the calculator, you notice how it looks like this? It should match relative to the shape. Again, I'm not going to be like, it's not curvy enough. But your line should be hitting the points that you found.
But how like accurate is this like, as
If you drew this, I would still give you credit. If you drew like this, I would be like, come on. Like, that's
as
wrong.
long as like as long as it hits
Oh.
the dots, you don't care.
Yeah, as long as it hits the dots and don't go over the asymptote. AKA, it should not go like that.
Wait, how did you know to put the diagram in the calculator?
Yeah, just look at the calculator. I can see the general curve. So,
And if there was like
Mhm.
a horizontal asymptote thing, would you have to stay under it for the other one?
yeah, you'll see how it looks. So I'm going to do
I
another
mean,
one.
it's even
also.
weirder though on the calculator, because like, I don't see the line where the asymptote is.
That's why I'm asking you to graph the line so you know where to draw the thing. So draw all the things you found first and then follow the calculator.
We just make a circle and then
A circle and a line?
like
That's
the
null,
dotted-
yes.
dotted line.
Or you could just say no horizontal asymptote if you want to write out the words.
No, on the graph itself.
I just write
there's a
no.
dotted line,
The dotted lines is based off the horizontal asymptote, vertical asymptote, yeah.
but there's no, it's just zero.
Is null, so there's no, you can see there's no
So I
sideways.
can't- Oh, fine. Then what about the vertical? Oh,
That's that purple line.
so what are the two things?
Those are the x-intercepts. And this is the y-intercept, just to catch it. All right, next one. Let me pick one from the book.
Which the vertical asymptote being -2 says the values
I know,
are
I
on
might
the
be saying.
x-axis and y-axis whenever it's negative.
Say that one more time.
So the vertical axis is the vertical asymptote is
Means that there's no value on x equals -2. So it should be, if you look at your table, it should say error on -2. X equals -2.
yeah.
Yeah.
But you never exceed.
All right. For this one, we have a situation. Again, you still find the four things: horizontal asymptote, vertical asymptote, x-intercept, y-intercept. For this one, you have your p and q being the same thing. So px, p equals x, or p equals q, I should say. So when p equals q, you use the coefficients. So what does that mean? I take the numbers in front of the highest powers. In this case, though, x squared, what's in front of this if you don't see a number? 1. What's in front of this if you don't see a number? So you would just do, your horizontal asymptote is 1 over 1. Let me keep it the same color. Is 1 over 1.
So what?
So just 1. So you have a horizontal asymptote at 1.
So if they're equal, it's just the coefficients, and if the coefficients aren't there, it's just
1 over 1 in that case, yeah. But this could add a 2, it would be 2 over 1 in that case. All right, vertical asymptote. Vertical asymptote, we still do the same thing, which is make the bottom equal 0. So q of x equals 0.
And one is one like you go by the power.
That's the horizontal asymptote thing.
So you just go over one. Why is it not two? It's six.
It's the number in front that we go off.
Isn't it the exponent?
The exponent chooses which number you're looking at.
Oh.
Like I'm not looking at this number, I'm looking at this number. All right, so in this case, I'm going to make the bottom equal 0. So x squared minus 2x minus 15 equals 0. X minus 5, x plus 3 equals 0.
Are we gonna access like so the 4 points, or we just type in the calculator and graph it out?
No, you got to get me all these things. The x-intercept, like I'm not teaching you how to do the curvy parts of it because I'll allow you to just use the calculator on that part. But there is a way to teach that. I'm not bothering with that. All right, x-intercepts. X-intercepts, you make the top equal 0. So p of x equals 0. So x squared plus 9 equals 0. X squared equals -9. What's the issue here? Yeah, if you square root here, you have imaginary numbers. So in that case, there's no way it works. So there are no x-intercepts. You could write the words no x-intercept or write the symbol null. And the last one, the y-intercepts, that's when we plug in 0 for the equation. So 0 squared plus 9 over 0 squared minus 2 times 0 minus 15. 9 over -15 reduces to 3 over -3 over 5.
You could have multiple vertical asymptotes.
Yes.
So like that's like where the vertical asymptote is this, right?
Yeah, vertical. All right. So you have a horizontal asymptote at 1. So a horizontal asymptote at 1. So a dotted line at 1 up. You have a vertical asymptote at 5 and at -3. So 5 to the right, -3 to the left. You have x-intercepts. There's no x-intercept, so you don't have to draw anything in that sense. And you have your y-intercept is -3 over 5. So -3 over 5, which should be in between 0 and -1. And then I'm not going to be like, oh, that's actually half.
Why are there two vertical asymptotes?
There's two solutions to the bottom.
But we don't like, we haven't had that.
Well, you're about to see how it looks. All right, we plugged in everything we can that we found by hand. Pull up the calculator. X squared plus 9 divided by x squared minus 2x minus 15. Thank you. Scrap that. That's okay. So it looks like this. Let's draw that. Looks like it would be up here. And this is like downward part here, like an upside down parabola kind of. And then the edge part here. Remember, your curve should not be passing through your asymptotes. So if you drew your curve like this, you'd be wrong. You lose a point for that.
Yeah, asymptotes are like
Borders, I guess. You can't cross them.
Yeah, it's like all the corners you found.
It's the dotted lines here.
Is this black now like that?
There's when Q is bigger.
Oh, but
We
then.
have cubes, right?
What's up?
But you did
You ever have a cube?
Hmm?
The problem ever has it is like cubed and not squared.
What's up?
Oh.
But the problem ever has something that's cubed and not squared, for example.
Not for a test, though. Maybe a homework question had that, but for a
Yeah,
test,
yeah.
that'd be too tough. Or that's too much time. All right, so what do we got now? Well, P, where Q is bigger. Well, let me just pick something quick. X plus 1, x squared minus 4. So in this situation, P is smaller than Q, or Q is bigger than P. When that happens, your horizontal asymptote is automatically 0. Your horizontal asymptote is automatically 0. X, just not. Okay, so your horizontal asymptote is automatically 0, which is going to be the x-axis. Vertical asymptote, because I used last time purple. Vertical asymptote is going to be bottom equals 0. So x squared minus 4 equals 0. X squared equals 4. Square root both sides, x equals, don't forget, plus or minus 2. You could also have factored this as x plus 2, x minus 2, and then solve them. So it's 2 and negative 2. Next one is the top is 0. So x plus 1 equals 0. So x equals negative 1. Y-intercept, plug in 0 for everything. 0 plus 1 over 0 squared minus 4. 1 over negative 4 is your y-intercept. That's fine. If your horizontal asymptote is 0, your dotted line is on the x-axis. Vertical asymptote being 2 and negative 2. Beats a vertical line at positive 2 and a vertical line at negative 2. Your x-intercept is at 1, at negative 1, so it's going to be something here. And you're going to see this is the one case where something could go through the horizontal asymptote. You'll see how it looks like. And you have a y-intercept of negative 1/4, which should be in between 0 and negative 1. Now I said the asymptote you can never pass. In this example, you'll see it pass. It will make sense when you look at it.
What was that asymptote? The horizontal or the vertical?
It could technically pass the horizontal asymptote. And this is an example of when that happens.
What?
So then, goes along this way. Now, where do you think it actually crosses the x-intercept? It actually, or oops, I guess I missed. Not at 0, 0. It crosses the asymptote at the x-intercept, that green dot we made earlier. And this one should be on top.
Why is it crossing it if we really can't go above it?
What do you ask?
The horizontal asymptote is that no value can exceed it, correct?
The vertical asymptote is no value could be plugged in for that to work. Horizontal asymptote is that it should approach or should never really reach there. There's one example that occurs, which is this type of example.
And why is that? Why is that?
It doesn't matter why it's that. You don't really care. It just happens. In this one, just don't let it go.
Why didn't it go down like most examples?
I can't explain that without taking too much time. So, all right. In 5.3, in 5.2, my bad. In 5.2, you had this type of example. Wake up. In 5.2, you had it where there's no x on top. So when there's no x on top, you could do it either the 5.3 way.
Wait, it can't.
It's coming back on. You could do it the 5.3 way. Hopefully my computer doesn't crash. So there we go. So let's say something like 4 over x plus 3. Okay. So 4 over x plus 3. I should say y equals, or f of x equals 4x. So you could do it this kind of the same way as the other one, where you rewrite everything. But in this case, we're going to do it in this way. We have a parent function. Let me use a different color for it. Which is f of x equals a over x minus h plus k.
What kind of like, does this go at 5.1 or 5.3?
This would be exactly 5.2. But you could do the 5.3 version on this, technically. You would just have to put the 3 on the top of the fraction, but... All right. In this case, a is 4, h is 0, k is 3. The AH and K is the same AH and K of the pass. So this means you have a vertical stretch of 4. You have no left or right movement. And your K value is going to be up 3. Now, how does that affect your horizontal and vertical asymptotes? Well, your horizontal asymptotes, and vertical asymptote, in this situation, and this situation occurs when there's x on the bottom and no x on top. So x to the 1 on the bottom and x to 0 power on top. So your horizontal asymptote in a generic situation will be x equals your h, or I'm sorry, horizontal asymptote will be y equals your k value. So in this particular example, your horizontal asymptote is y equals 3. In generic, vertical asymptote will be your x equals your h value. In this example particularly, your vertical asymptote is at x equals 0.
Wait, why do y consider horizontal asymptote?
To draw a horizontal line, that'd be y equals something.
So it goes this way.
Yeah.
But at a certain point, well, this way. So I guess the horizontal asymptote goes the same way.
Yeah, horizontal asymptote is always described with a y. Vertical asymptote is always described with x.
I keep
That's fine, me too. This might be easier because if you notice is H and K, you can just plug in your horizontal vertical. Your x-intercept is when again? You plug in the top equals 0, but guess what? That can't happen. Why? Because 4 equals 0. That doesn't reduce anything. If you make the top equal 0, 4 equals 0. Is there an answer to that? No. So,
You always make the top equal 0?
yeah. And then the y-intercept is you plug in 0. What happens if I plug in 0 here? Why?
So you can, there's nothing wrong. X equals 0.
You could plug in 0 into the whole thing, but what's wrong with this?
4, it's not a thing. 4 over 0 is
It's undefined, so that's
How do you
no.
find the x-intercept?
You make the top equal 0.
So 4 equals 0?
4 equals 0, but 4 equals 0 doesn't mean anything.
But the plus 3 is included.
Oh shoot, you're right.
Oh, come on.
Undefined
Doesn't
equals
count.
3, so it wouldn't work either way.
That's not true.
Let's try that.
My fault.
If
With
he's
the-
confused, then like, the whole class is like not ready for this time.
no, I messed up.
Ah, you still can't do
Is
it.
it just
I guess on this example, I want to give you x and y intercepts. Whatever.
Okay.
All right, because I messed up. Because this 3 makes it harder. So
You're welcome, guys. I got you.
either
So
way,
now what? We just leave it at that?
yeah, you just asked for vertical and horizontal. So when you graph this, you're gonna have a horizontal asymptote at y equals 3. A horizontal asymptote at y equals 3. A vertical asymptote at x equals 0. There is an x-intercept, which I'm going to show you how to solve it. Forget it. I went back on my word.
Wait, what?
X-intercept. How do you go to solve the x-intercept? You need this to be in one fraction. So how do you make this into one fraction? You have to put this over x, which means you have to multiply this by x and rewrite it as 4 plus 3x over x, which now you can set the top equals 0. So that is, what's up? I have to change this denominator x to make it one fraction.
Wait, is this a new problem?
No, same problem.
So why do you go over this? Why do you get over that?
Because, wait, what?
You put like 3 x's.
Yes, because if I put an x on the bottom, I have to put 1 on the top.
You just
And
added
it,
an x.
yes, I add x over x, which is okay because that's still 1.
Wait, so what did you do? Wait,
So
why did you add?
So I need to be in one big fraction. Problem previously, it was not one big fraction.
So what's the original problem?
This.
Okay.
And then you're going to do times x over x here. The reason is I want the denominator to be the same. Would that make sense? So then it's going to be 4 plus 3x over x. If you want to do this 5.3 version, you would need to rewrite it like this. I was going to tell you later, but you're going to rewrite it like this in order to do that. So then the x-intercept is going to be the top equals 0. 4 plus 3x equals 0. Solve that. A little bit of algebra should tell you that's negative 4 over 3. Negative 4 over 3, which is over here. What's up?
You canceled out the x's.
No, you only, an x-intercept, you only make it on the top part.
Oh, how do you get x equals negative 4 over 3 then?
Minus 4 divided by 3.
Oh, the x is in cancel.
Yeah. And then our y-intercept,
4 plus 3 times 0 over 0.
yes, but the problem is it's still over 0, so it's a null. Okay? Oh, you plug this in your calculator, it's going to look like this. And then let me just plug it in the calculator to confirm for you guys.
Wait, how do you find the y-intercept?
You would plug in 0 in everything. The problem with that, though, is what?
That is there's a 0 under it, so it's null.
Because 0's on the bottom, it's undefined, so it doesn't exist. No.
I think what's gonna screw me up is all the little rules, like.
Yeah. That's the whole section.
Wait, where do you find it? Oh, this class.
No.
Thank God it's Friday.
It's gonna be so hard.
All right, everyone, have a wonderful day.